It gets too loud.
Yeah, probably hear me too much.
How was yesterday? Have you learned something new? Just raise your hand if you learned something new in order to just do some small exercise. Great. I'm glad that you learned something new. And we hope that you will be able to learn something new during this session. And our talk is about the state of reactive database access. And since we really care about your ability to learn something new and that you will be able to gain as much as possible from this conference, we would like to start with giving you some understanding of for whom this talk. So this talk is for reactive programmers.
For those who do reactive programming each day.
And for those who learn apps.
Yeah, for performance geeks who wanna do a lot of performant applications. And yeah, I've spoiled already it for those who love or hate Hibernate, because a little bit later we'll talk about it also. And if you are just a curious developer, you're also at the right place. And we assume that you know a little bit about reactive programming.
But I guess it will be better to ask how many people are doing reactive programming or had experience with reactive programming at least. Okay, that's great, a few hands. So, if this talk fits your needs, then welcome. Today with me, my colleague Igor.
Hello, everybody. I'm working at Zoom Data. It's kind of Ukrainian part of a big startup. We are based on the Tsiklum platform here in Kyiv. By the way, Zoom Data is hiring, so if you kind of do not like your current working job, your place of work, Zoom Data is kind of cool place to work.
They're doing reactive programming, by the way, as well.
Yeah, we do a lot of reactive programming internally, so if you're interested, welcome.
And my name is Oleh. I work for Netify. It's a startup as well. We are doing reactive programming a lot. We are creating our socket, which is application network protocol. And I'm one of the contributors to Project Reactor and helping with organizing this conference and many other big conferences as well. So, also we are authors of this book about reactive programming in Sprint 5. So if you are curious about reactive programming and reactive database access, this book explains a lot about that stuff as well.
Also, most of the part that we are talking today is covered in that book already. So, kind of, if you miss some points, you are welcome.
Yeah, a little bit of marketing. So, what we are going to talk about today?
So, we want to a little bit understand or highlight why reactive is important, kind of for day-to-day development. Also, we will talk a lot about how reactive programming improves ability to work with NoSQL databases, as well as SQL databases like Postgres or Microsoft SQL. And we assume that you are a little bit acquainted with Spring Framework. Who of you use Spring Framework day to day? Okay,
great.
Most of you, cool.
So, let's start our conversation and let's start with understanding what's wrong with the blocking IO world. So, let's take a look at the really simple example. We have client application which calls our server. So this is a plain communication between client and server responds with some data. This is everyday communication that we are doing, I guess, and that we are building. However, the problem with blocking IO that in case we got more and more clients, our service could easily be overwhelmed and clients will get low latency and will get bad experience, which is unacceptable for real-world application. In order to show why blocking isn't good, I'm going to show you a small demo application. I'm going to show you a socket server, blocking socket server, and I'm going to do really simple application that just respond echo message to our incoming request. So let me do this small application first. Here is just JDK and nothing more. JDK basic, and this is server socket, which was introduced with Java 1. And here I'm going to run this application and going to open my terminal in order to do some communication with this service. So here I'm going to send some messages, and as you can see, I'm receiving, oops, I guess it's a little bit better, and I'm receiving the response, which is good. However, the problem is that if I open a little bit more connection to my local host and start writing and sending some data, nothing will happen. The problem is that we have everything blocking. Oops. Everything is blocking, so one of the options to improve this application is, of course, introduce some executor service, and we are going to introduce just directly, for example, cache thread pool, because we know if we just get a little bit more threads, nothing has happened. So we are going to introduce executor service, and we are going to run the logic on the separate thread pool, and we'll process everything kind of asynchronous, but with thread per connection. So we are going to do that. We are going to wrap the logic related to data processing, and yeah, everything should be also be kind of exception safe. So I'm going to restart this application, and now it should be better. Let's take a look at that. Let's switch to our application again. Let's connect. Let's start sending some messages. Yeah, it kind of works, but what if I'm going to do a DDoS attack, for example, on our service? I have a small application there, which is, let me show you this application, which is basically connects to our service and starts sending some data, like hello DOS attack, and reading the result of the conversation between client and server. So let me just run 5,000 of simultaneous connection. From the first glance, it's nothing for real-world application, right? So let's try to run this application, and let's try to see whether it will work or it won't work. So it starts opening connections. It's opening connection, opening connection. It will take a little bit of time. By the way, how do you think? Will it work or won't it work? Any ideas? How do you think? Will it work?
I suppose it won't reach 5,000.
I think so.
At least it's kind of already stuck somewhere at 4,000.
Yeah, looks like it's stuck. And if we are going to try to open, for example, a connection, a new connection there, again, we are going to see that nothing will happen. And nothing will happen because our application has crashed with out-of-memory exception, which is a problem. So let's just stop this evil application. There is a chance that my computer goes down as well because of this DDoS attack. But let's try to back to our application, and let's do some summary. What do we really want to see from our cross-network communication from client to server?
We want to see very efficient handling of network connections. So ideally, when client opens WebSocket connection to us, we want to be able to serve as many clients as it's possible, and our application can serve only 4,000 of them. It's not really big number. And a few years ago, guys from Spotify probably showed the ability.
Yeah, this happened.
Yeah,
my computer went down. So yeah, as I say, DDoS attack was successful.
It's kind of real stuff that may happen with your server also. At least your Docker containers will crash. So let me continue from my computer. Oh, yeah, clicker from other computer. So we want to handle connections efficiently, kind of. It's not only about communication rate, how often we can ask client send request to the server. It's about how many connections we can handle at least. And for incoming and also outgoing, if you're doing opening outgoing connection. And usually we use connection per thread approach. Who use this? Kind of, it's standard server approach when you kind of create a new thread and doing, all that stuff. And each thread is not cheap in Java. At least 1 megabyte and kind of sometimes more. At current project, we had to increase stack size for the thread to up to 4 megabyte for one service due to some reasons, kind of. And in that case, that service would be able to handle 4 times less parallel connection kind of than other services. And also, we would be bounded by some thread pool, which won't allow us to go beyond some number. For example, JDBC by default allows you 200 threads. You kind of can configure it, but 201st request you won't be able to serve. If you use something like unbounded thread pools, it would end up similarly to what happened with Oleh's computer 5 seconds
So my computer is up now. I can switch to my computer back again. So a couple of years ago, I guess 10 years ago, was introduced Java 1.4, and with Java 1.4 was introduced something called Neo. How many of you heard about Neo and had experience with Neo or has experience?
Oh, cool.
Okay, a few hands. So in general, Neo gives us a way of non-blocking communication between client and server and allows us to build non-blocking server. So in the case of non-blocking server, we don't have any kind of barriers, and we can handle as many requests as possible with a minimum amount of resources. So let me show you now a non-blocking server, and let me make you sure that non-blocking is much better than blocking. So here is my previous server, and now I'm going to write kind of reactive non-blocking. This is an implementation of simple reactive server which does almost the same. Do you see it? Okay, I hope you see it. And I'm going to run this application right now. So it does almost the same, like receive some messages, in this case by buffer, and respond with echo message back. And yeah, let's try to open terminal again. Let's try to do telnet host 8080. Let's start to send some messages. It works, which is good. And now let's try to run our evil application again, our evil doser application again, and let's see whether our service will be able to handle this. Yeah, it is. It is able to handle all this amount of open-end connections, and at the same time, it works very well. Nothing has happened because we only have a few threads which process all this amount of connected clients, which is good. All right, let me kill this application in order to save my computer this time. And let's back to our presentation. So, what do we want this time, and what we have seen?
So we want to serve many connections per thread, so ideally really a lot of them. And in very efficient applications, we have the amount of threads as the same as the amount of cores. So kind of to serve 5,000 requests, having only 4 cores, we need something like more than 1,000 connections per thread. It's much more efficient. It's kind of from standpoint of memory, 3-fold better than previous approach. So, and there are kind of very strict rule there. We cannot block. So we are not allowed to block somewhere any of that threads. So if you have 4 threads serving 5,000 connections and accidentally we blocked some of them, somewhere in the code, only 4 blocked threads will bring down our whole application. So for blocking, we need to move all that stuff to some external thread pool, or kind of other thread pool, not to block the event loop. But it's another story. The rule is simple: do not block.
All right, it's clear. So let's move a little bit further and let's try to look at the real world. And the real world is most likely microservices. How many of you are doing microservices? A lot of hands there. So microservices, I guess, could look like that. So we have a ton of traffic which is going and routing between many, many services, and they somehow communicate between each other. In our case, our microservices communication will be a little bit simpler. So we have a list of clients again, we have our server, and we have another server. So in this case, what could happen that our server is non-blocking, but we use some blocking client, and we won't gain any benefits of non-blocking server, which is also the problem, right?
Yeah.
So let's see at the demo. This time it's...
So it's my turn to do a demo. We have two services, as we just saw on the presentation. Kind of one, the external service. Do you see it? Or it should be a little bit better. So, okay, we have external service. It's pretty simple. Webflux application, it's non-blocking. We serve one request, something like, give me the data for some region, and we introduce artificial delay. Do you see it, or should I make it bigger? Okay, everybody see it? Cool. So we artificially generate some delay to test our application, because it's not what we're testing. It's kind of external service that serves us as a kind of connection point where we are going to work with. Also, it has ability to kind of say the amount of requests that it serves at the moment. Kind of, let's forget about that. Also, we have our super application. It's a little bit more complicated. It's also a reactive web application. It serves a little bit more of the more requests. Kind of, we have also here one thread pool, dedicated thread pool. So every operation that is blocking in this application, we will do on the separate thread pool that we will continuously monitor to understand how many resources have we at the moment, kind of for another blocking operations. All non-blocking operations should be handled without any limitations. Kind of, do you understand that? Cool. So here we have our external service client, and we will do very simple ability to switch to communicate with external servers in synchronous way, and later on in asynchronous. Also, kind of, this application is currently running external service and our reactive application. Cool. And we have, okay, go away, please go away. So we have application at localhost 8080. This is a simple web application that gonna communicate with our external service, and that external service gonna provide our weather report for today. So I'm going to be kind of to simulate a lot of clients that communicate with our weather service. I'm gonna click on some regions, and that each of that region will generate a request to the external service. Also, we have this kind of important part, it's thread pool usage. So now we have 4 threads. Usually we would have more, but to exaggerate the problem, we reduced it to some a little bit less, kind of, to the smaller thread pool. Also, this is a queue. How many tasks we are queued for blocking operations? Kind of. I assume that you know that before going to the thread pool, tasks may be queued if thread pool is full and cannot process new requests. So you know that. Cool. Also, we may show how many requests we are serving at the moment and how many requests external service is handling at the moment. So kind of, let's make some requests. As you can see, we already kind of made our thread pool up to the limit. Okay, let's reconnect probably. Yeah. So now you see that if queue has some elements, we are serving for request, and external service also serving for request. And external service won't ever receive more than 4 requests from our service because we're doing blocking EO, and our blocking EO is limited by that thread pool, kind of. So you see that for today, the middle part of Ukraine is going to be cold, and other parts would be hotter. So kind of, this is applications that we will explore later, adding new features. So kind of, we may go back to the presentation.
All right, let's switch back to our demo. So what we can do regarding that? First of all, we can use, instead of blocking client, we may use non-blocking client. What do we have today from, like, what kind of non-blocking client do we have? First one is, of course, is Neo. We can use Neo directly, and we can communicate through socket channel, and we can do some communication with external servers using this low-level API from JDK. But it's not fun. Thus, we can use, for example, Netty client. How many of you are aware or have had experience with Netty? Okay, a few hands. So Netty has non-blocking client, which allows us to do that communication non-blockingly and asynchronously. Also, recently we got a Jetty client, which also non-blocking and allows us to work non-blocking and asynchronously. And maybe a month ago or 2 months ago, we got JDK client. So JDK 11 introduced non-blocking HTTP client, which allows us to do the same communication, but asynchronously, non-blocking and even reactively, which is important for us. So let's take a look at how this communication could be done. So we may do almost the same, but in this time, no blocking request will be in place, so everything will be fine and processed almost simultaneously. And let's now see what we can use for our application. We can use Spring, for example, in order to build our server. We can use Webflux, because Webflux in real modern application is a good technology to serve a lot of incoming requests from the client. And we can use Web Client in order to send requests non-blockingly and asynchronously. How many of yours are using the same stack on your project or planning to use the same stack? Just a few hands, all right. So let's now see how this could be done and how this could work.
Let's go back to code. This is our external client service, kind of client for external service. And we have 2 methods here. I forgot to show you sync request, how we do synchronous request. So we're using a new HTTP client, kind of, here he is. It's from, you should see, JavaNet HTTP from version 11.
So we are using cutting-edge technology.
Yeah, edge technology. However, we use in blocking way. So we can say block and do a kind of return request in the blocking way. We've already seen how it works. Alternatively, we may use a web client from Spring 5, and it works with Java 8. And here we do the same. However, it's non-blocking, so it's simple making requests for correct URI with timeout configuration, do all that mapping. So let's return to our demo. So I will reiterate, this is synchronous, kind of, you should see, and we're using blocking operations, and we use thread pool. So now we may go to async. Okay, let's go to async. Okay, so it's finished previous tasks. And now, when we're doing the same stuff, we have no need to block anything, and kind of it still has some latency because we requested the latency for external service. However, our thread pool is not used, so we haven't done any blocking operation so far in this async application. So it's kind of all the cool stuff that bring us Spring 5 and non-blocking communication. By the way, it's weather report for tomorrow or day after tomorrow, so kind of it would be much more cooler here than at the moment.
All right, let's go back to slides again. And what we have seen is like part of microservices communication. However, real world is a little bit different, because in real world we have databases. I guess how many of yours are using database in your project? I guess everyone, right? That's a stupid question. So in this communication, along with microservices communication using HTTP client and web client, could be used communication with database as well, because database is an external service also, right? So what we have with in like communication, microservices communication today?
I think we need to search Google for reactive Spring data. So kind of Spring introduced last year a reactive stack for web and also for database access. So now we can communicate with databases in that non-blocking fashion, so that it should be pretty efficient. So kind of what we have there. So the first stuff, the first database that we support there is Cassandra. Who of you have heard something about Cassandra? Okay, cool. And who of you have used it? Okay, still a couple of guys. Who of you have used it in a reactive fashion? Okay, yeah, we have people also there. So,
all right, let's take a look at the demo again.
Yeah, okay, so my turn. Our application again. So we've closed our external service. We still be doing requests to our external service. However, from now we assume that all requests to external service are done in non-blocking way. So kind of we are fine there. This is our database facade that kind of can work with different databases. I have already spoiled some of them for you. And now we go to research. Now we are going to query Cassandra.
So this is a weather report for the world?
No, it's GDP report. It's okay. GDP for countries. It's kind of couple years old. However, it's just a data set that we're using for demonstration purposes. We're doing two requests. One for external service to get the caller value, and the second to database to do some actual number that we show on the here. So if everything goes well, we should see that nothing is blocked, and we kind of, with some latency, receive data, both from external service, callers from external service, and the number from the actual database. Kind of, I may even show you logs, and if everything is well. So you see that we are executing SQL statement, some statement. So actually, it's from Reactive SQL template, which is a part of Cassandra. So it's doing actual Cassandra requests.
Yeah. All right. So, but let's first try to understand how the Cassandra driver works and how whether it's really reactive or it's not really reactive. Just a moment. Yeah. Yep. Here we are. So what is going on under the hood in Cassandra? Cassandra driver is built on top of Netty again, so almost every database and driver use Netty under the hood. And what is going on when we start querying some data? We send the first request, then Cassandra prepares some response for us and send a batch of rows to us. So what is going on? We send the request and Cassandra synchronously responds with some batch of data. Then we are going to request some portion of them. For example, we are going to request one. We can request a little bit more, and driver will send the response back to us. What problems do we have there? First of all, we don't have really kind of streaming. We have batching. We send a query and return and got as a response a batch of data. So we have to wait for this batch, of course. Another problem that we have to store this batch of data, this huge amount, possibly a lot of data in memory, which is another problem. However, Cassandra has some options for us in order to solve that problem. We can, for example, use fetch size. Do you see it? Okay. We can set up for query options a fetch size and say, okay, Cassandra, we would like to just get a small portion of this data set. So don't send any all the data set to us. And in this case, if we're going to set up this this property, the communication will be like following. We can request a portion of data. For example, we are going to request end elements from the database. And since we have a fetch size only 2 elements, we are going to query for data and receive exactly 2 elements, 2 rows from this from the response. And then we are going to do another round trip and receive some data back, another round trip, and so forth and so on until we grab all the data set to our application. So it's a little bit better because we don't keep all this information in our application. However, we have to do too many round trips, and this is kind of a problem because it's not flexible. Okay, let's go inside our application and let's see how it works under the hood a little bit closer in order to understand. Wait a minute.
Yeah, so we want to experience, at least try experience, that it's actually doing some batching, so we do not load all the data, kind of. You may do some analytical request, and loading 1 million of rows in one batch might be not the best idea, kind of, especially in Reactive world. So we try to use some cool number, like 13, to actually...
Like a number.
Like a number to call it. And also I've put a breakpoint somewhere in the internals of the Cassandra. Hopefully it's correct one. This is the place where Cassandra reactive driver.
I guess it's not Cassandra, it's Couchbase.
No, it's okay, yeah, it's not Cassandra, it's Couchbase. Right, correct, incorrect breakpoint. So probably this should be no.
Yeah, this one, right?
This one reached. Yeah, this is the correct one. Sorry, too many databases for one day. We have kind of result set that we receive kind of a batch. So here we translate the reactive streams to the batched approach of the Cassandra for communication with database itself. So we have a breakpoint. Let's do some requests. Hopefully, yeah, we've caught it. So we have next result, value, and kind of you see current page size 13. Most likely it's the correct 13 that we asked. Oh, we may do another one. So we are getting results in batches of size 13. We can configure it. At least it's kind of the pretty primitive approach for mapping the reactive way to the asynchronous way, but at least it works and it doesn't block application.
However, it's not flexible that much, right? Because the user could request much more higher number of data, and Cassandra will be only able to send us some portion and have to do some round trips again and again and again.
Yeah, and kind of this is static variable. So we may say 13, however, for some requests it won't be enough, and we would be like to have more flexibility in that area.
All right, let's go back to the slides again. And let's do some small summary. First of all, the good part of Cassandra database is that it is asynchronous and non-blocking, which is good for us. However, the bad part, there is no streaming support, which doesn't fit reactive programming approach, right? And the ugly part is that even we can configure Cassandra somehow, we can tune it a little bit, the fetching is inflexible at all, so we can nothing to do with that. So what else do we have then? We have a Mongo database.
Who of you have ever used MongoDB? Okay, much more than for Cassandra. Kind of it's much more popular. Who of you have used it in a Reactive way? Okay, still
a few hands.
Yeah.
All right, let's look at the MongoDB demo right now.
Yep, requesting the monitor again. So the same application, go again to the next kind of demo. We have now the map of the continent. What continent is it? Do you know? Yeah, it's Europe. So kind of, and we are doing the same stuff with the Mongo database. So we are making the request to external service in a blocking way, and also we asking for population number MongoDB. So the data is stored also there. So kind of, we may start from Ukraine. It should be something like 44 million. What is the biggest country in Europe by population? How do you know? How do you think? Germany? Yep. Let's compare. So Germany 82 and Swedish 9. So kind of a little bit less. So can we might do all that stuff as kind of previously. So we may kind of.
As I can see, everything is asynchronous again.
Yeah, we do not block. We still do not block. We do all that requests similarly, and our application should also report in console that now we are using some Reactive Mongo template and doing some requests, kind of, and it works.
All right, let's back to slides again, and let's try to understand how MongoDB drivers works. So MongoDB driver is also built on top of netty. As I said, everything is built on top of netty. However, Mongo driver is a little bit better. We're going to cover the same case again, but with MongoDB driver. We requested 8 elements, and Mongo in this case returns 8 elements back to us, which is better. So as you can see, let's take a look at this again. 8 requests, query to Mongo, 8 response, all 8 response back to our client back. So the MongoDB driver is much flexible than Cassandra driver because it allows us to control using reactive streams approach, control the amount of requested. You could use back pressure, for example, in order to say, I want to 8 element, I want to 10 element right now, and we get for one round trip 8 elements back. Of course, if MongoDB has. However, let's first look at the code again.
I think that it's pretty similar. Let's keep it kind of for.
All right. So let's keep for this time the MongoDB demo.
It works in a similar way. However, we may kind of change this size of the batch kind of on the fly. So
all right.
Kind of.
So the good point for MongoDB is the fetch size is flexible right now. However, the bad is that no stream support again. So we do batching again. We request 8 elements, and we have to wait for 8 elements, and then we only when we get this 8 elements in memory, we can send them to the client back, right?
Yep.
And ugly part is that MongoDB just ugly, and that's it. It's not efficient that much, right?
Yeah.
What do we have else? Do we have something better? I guess we have better, for example, we have better Couchbase. So what could we say about Couchbase this time? Are you going to look at the code?
Yeah, let's go to demo. So who of you have ever used Couchbase? Who of you have ever heard about it? So kind of they kind of promote that is better Mongo. So let's look at it. So now we're doing the map of world, and now we're gonna look at the population density, how many people live on the square kilometer of the area. So and now we're querying the Couchbase, kind of, and it's also doing all that asynchronous work. And somewhere here I should have cool stuff. Okay, Couchbase UI.
So Couchbase has a pretty UI for understanding what is going on with Couchbase, and we can look at
we may kind of look at the queries. So let's go again to our demo, make some more requests, and we should see a spike somewhere. So I think for Greenland, not a lot of people live there. And yeah, you see that we kind of serving requests, and all this stuff also happening in a reactive way. What's cool that kind of underneath Couchbase receive kind of do not do batching. It's actually doing streaming.
Yeah, let's look how Couchbase drivers work this time. So Couchbase, again, use Netty under the hood. However, this time we have kind of reactive communication. So we create a channel between our client and between Couchbase, and we say, okay, Couchbase, send us all the requests asynchronously and non-blockingly and reactively, which is most important. And we won't receive any kind of batch anymore, but we will receive one by one elements and we'll be able to process them as soon as possible. However, there is one problem with Couchbase. We requested just now. And Couchbase doesn't have any backpressure support. It's RxJava based. They have RxJava based client which doesn't support any backpressure.
RxJava 1, so it's still on RxJava 1 and design protocol design over it, so we do not have the notion of backpressure.
So our application could be easily overwhelmed by Couchbase data, which is not good. So our application have to buffer somewhere all this data in order to be able to send them with backpressure to another service, for example, which is a problem as well. So are we going to look at the code this time?
Let's look for a second.
Okay.
So what's cool that in this place, as you can see, we do not operate with batches. We actually receive a stream observable from RxJava 1.3.8. It's last stable of last supported of version 1 RxJava, and underneath we're receiving byte buffers from Netty, I believe. So it's doing Netty request and bytes are streamed to us, and kind of buffer by buffer we transfer them to rows and push to the reactive application. So it's kind of cool there. We may kind of put the breakpoint, but it would be trivial to see that it's actually streaming data.
All right. So let's do sum up about Couchbase. It has streaming approach, which is better than previous databases. However, Couchbase doesn't have any backpressure support so far, which is bad. And the ugly part is the design which doesn't support backpressure under the hood, so we, I guess, couldn't do anything regarding that. All right, so what do we need? What do we need to mention also?
We also haven't mentioned one database that's also supported reactive connectivity in Spring. It's Redis. Who of you have ever used Redis? Oh, cool. It also has reactive support. It's a little bit low level than previous one. However, it's also there.
Yeah, we are not going to talk a lot about Redis because it's a key-value storage rather than database, but we are going to talk about the future. What do we want to see from the database support? From the database support, we want to see the following, like from the directive communication with database. What we want to see is the ability to create the same connection with database between client and database, and then query some data, and after that point, nothing should happen. Because the things should happen only when we send a request to database, and only after that the database should start generating some data and send them back reactively to our client. That's exactly what we want to see from the database support, right? And
something like Couchbase, but with backpressure support.
With reactive Spring Data, currently we have only those database support, but as you can see, as someone might notice, there is only no SQL database, right?
Yeah, and what about SQL? So kind of
we have to ask, how many of yours are using SQL in your project?
So,
okay.
Yeah, sources are known, kind of. However, they say somewhere on the internet that 80% of projects using some kind of SQL databases as a data storage. And what defines the SQL connectivity in Java? What do you think? I can hear. Yeah, correct. JDBC. So kind of the obvious question: make it reactive, kind of. What do you think? How can we do it reactive?
Who think that we can do that? Just raise your hand. Okay, just a few hands.
So, what do you think? Can we wrap it in a thread pool, kind of make a reactive API over it and use it as is? How do you think? Yeah, kind of. We still could do that. However, in our application, we will use blocking thread pool because it's still blocking. It was designed as a blocking API, and there are no way, at least do it asynchronous, not saying about reactive. So kind of, there are projects that are doing that, like React Java 2 JDBC on the separate thread pool. However, that approach doesn't scale. Kind of, it's just a wrapper for blocking code for reactive application. It plays a little bit better in the code. However, it doesn't perform as well as we would like.
So it's kind of hacky way, right?
Yeah, it's hacky way.
It doesn't work like that.
So we have some requirements for our reactive
Database
JDBC
connectivity.
Kind of alternative. So we want it to be non-blocking. So it ideally, kind of, it's must-have. It should not block any threads when doing requests, or at least API should not require driver or client block a thread. Also, we want it to be designed for streaming of data. So kind of not request response, however, request and stream all that results set you have kind of one by one or batches, however, stream it. I do not want to receive at once 1 million of the responses from database. Ideally, we want to have back pressure support, so kind of without it, it doesn't play well with reactive stream specification and flow API. So it's kind of the main stuff we want to require from it. Kind of now I have to say that after this point, everything we show is highly experimental. Do not use it in production, kind of, or
you can try, of course, but
you better not.
Yeah.
At least so far. At least in half a year it could still be possible. However, at the moment it's not the best idea. So kind of. So do you know of some alternatives, kind of a JDBC that's already somewhere discussed or kind of designed? Have you heard about something?
Okay,
so,
one hand.
So first one is ADBA. So it's asynchronous database access or API, something like that. It's designed by the Java group somewhere inside Oracle, and they are designing it as in asynchronous way with completable features in mind. So in best case, it would be something like Cassandra client without streaming, kind of, and mostly with batching. However, it could be non-blocking. It's not enough for the moment, and there are a lot of people requesting the group, guys, kind of, why can you add a reactive API, and kind of over reactive API, it's really easy to add a layer that will return completable future, and Java already have flow API, that is reactive API. Why don't do that in that way? Kind of, we have HTTP client that is reactive already in Java 11. However, they are against it, at least for now, kind of. So ADBA do not fit us. I won't show you demo. However, I'll show you code. I make request for a screen. So it's in development for 3 years now. They do not have any connectivity besides this project A of G. It's ADBA over JDBC. So just taking JDBC, wrapping in a thread pool, and doing kind of asynchronous requests just to validate the approach. Most people who try it, say that it's ugly. So it's kind of okay when doing requests for one element. However, it's much more harder to request a stream and try to do all that stuff. You will need the same wrapper as for Cassandra approach. So kind of, and it's most of the people in the reactive community thinks that way. However, Oracle is still not convinced enough to kind of promote it to the ADBA. So let's go to presentation again.
All right, so in a few words, ADBA has some bad points, like it's not reactive, which is not useful for us because we are reactive guys. We want to have anything reactive and fast and resilient. Not DSL like in the reactor, so we don't have that much of useful operator which allows us to transform data to process it one by one. And we don't have any back pressure support, which is like which means that we couldn't make our application resilient enough. Also, not ideal for data stream at all, so it's just for request, response, and receiving some batch of data. But what could we do better?
So about a year ago, some guys in Pivotal, do you know what Pivotal is? So for those who don't, they are doing Spring Framework, so kind of they already know what is reactive programming, because they've done WebFlux, all that stuff. They decided to kind of show Oracle what R2DBC could look like in a reactive fashion. So at first it was just API, then implementation, client, all that stuff, and after a year of work, they have much more results than the previous approach for 3 years. So it's composed in a couple of layers. Let's start from the middle one, SPI. It defines the API for drivers. Kind of what was bad with JDBC, that JDBC API is both for client and drivers. So your stuff that working with networking has to implement API that should be convenient for end users. And usually it's not. Who of you use JDBC directly? Couple of you, and who of you use some wrappers like JDBC templates, repositories, kind of much more people. So yeah, it's not convenient to use JDBC, and so they decided to design minimal SPI, so you kind of may implement 5 classes to get your driver. So it's cool, it would be much more easier to implement drivers. Another stuff that they have kind of client API, it's a library that is implemented over it, and it may be as convenient as you like. So it may have some code generation, some useful stuff for tricks with SQL, and so on and so on. And another kind of layer, last layer, is drivers that implement SPI. They started with Postgres, kind of as a demo one, and kind of other databases. Also, there we have R2DBC over ADBA, so kind of that hack that will do the same stuff that Cassandra driver doing over Reactive Cassandra driver over Cassandra protocol. So it's still possible, however, it won't be efficient, and kind of probably there would be also ADBA over R2DBC kind of. And at the moment they are kind of competitors, and who knows who will win. However, I'm for R2DBC. So let's go next. So for there we have at the moment experimental drivers for Postgres, for MySQL, MariaDB. You never kind of will guess what would be next. It was kind of very surprise for me, but they have a driver for Microsoft SQL.
They just recently provided the support for MS SQL.
Yeah, and also they have H2 probably for testing, kind of for do all this stuff, testing in internal. So, demo
Let's
time.
take a look at the demo again.
So, let's go to other project. I have here a simple application somewhere here. Yeah. So, we have configured R2DBC. It's a little bit, so it doesn't have auto configuration yet, but it's coming soon. And we may work with it like this. So we have database client, so it's kind of transactional database client where I can execute SQL, kind of do fetch, and kind of return raw updated. And what's interesting, it's returning mono of int. It's already reactive from the design. Kind of we may do more stuff like inserting rows, and we may do something even in transactions. So we may say in transactions, and we get in a session, and all the stuff that we'll be doing in that lambda would be done in the same transaction. It will commit or roll back atomically. So kind of from the beginning, we have some transactional support. So in here we have example. I won't run it. However, we can do many operations in transactions and kind of then react to the results of it. So let's go back to presentation.
All right, I'm going to switch back again, and let me start with some criticizing R2DBC from my point of view. First of all, this project is in alpha. It's funny. This project is in alpha, and there is no real project that validated R2DBC yet, which is another problem. Also, there is no Hibernate Eclipse integration. By the way, how many people use Hibernate there?
And I have bad news for you. At least guys who are developing the Spring Data in Pivotal say that there won't ever be. So kind of that approach won't apply to reactive streams at all, kind of all that caching and memory kind of applying. Maybe someone in a couple of years find out how to do all the tricks for reactive programming. At the moment, nobody knows how to do that. So there are no chance that it will be reactive GPS soon.
And finally, what about transactions?
So we will talk a little bit about that later. However, all these things that we do in transactions, kind of with reactive streams. Okay, so let's do it short. When we do transaction, we want to do it as small as possible. Yep. So kind of the database won't do a lot of contention, and kind of transaction won't compete with each other. With reactive streams, we kind of say, okay, make a query, or give me one row, and then one row. Okay, I wait, then one row, and now 2 rows. Okay, I've done, complete the transaction. And for all that time, database should kind of store that transaction somewhere. It may increase the contention. We do not know yet, because nobody using that in production. However, it's kind of pretty reasonable problem that we may face. However, it also depends on the transaction, kind of. For Mongo, it's not a problem. Mongo.3 do not have transactions at all, so kind of, it's fine there.
And the final point, what about Spring integration? I love Spring, and I guess everyone in the room loves Spring again.
Let's look at this slide again. Now we have one new kid on the block, Spring Data R2DBC. So it's kind of cool, because now we have ability to do JDBC connectivity, or kind of SQL connectivity through the repository, similar reactive repositories, similarly to Mongo, Cassandra, or other stuff. So kind of we may go to demo now.
All right.
So let's go now to JDBC. So this is another sample data set. And for database, we're using JDBC wrapped in thread pool, something like Rx Java to JDBC. And now when I'm making requests, you see we're still filling the EO thread pool kind of, yeah, it's not good. So we've wrapped, it works in reactive application, however, we have to block. With R2DBC, we're doing the same stuff. Okay, it's still JDBC returning results. Okay, it's calm now. So now we're doing the same stuff with R2DBC, still waiting, still some simulated delays on the database and external service. However, now we do not block a thread pool. We do not have queue task and all that stuff. That is kind of cool. And in code, I would simply show you that we have it was US sales R2DBC. It's R2DBC repository that extends reactive CRUD repository, similar to CRUD repository, but in reactive way. And we can do something like queries. This is how I simulate the delay from database. Cool stuff. So you may kind of write this intentionally scale that will run for a long time. And we return in mono or flux with our objects, and we may kind of operate with it from JDBC for DBC seamlessly with web flux. So with web client, web flux, all that stuff even doesn't require any conversion between each other.
All right, go back to the slides again.
Yep.
And we are out of time, I guess. Let's do some summary.
Yep.
First of all, let's say that reactive enables efficiency. So you want reactive because you want to preserve your resource, you want to utilize your hardware really efficient, you want to save customers money for the cloud, for hardware. That's why you want reactive, because reactive is for efficient and resource utilization.
Yeah, we have reactive persistent for NoSQL databases like MongoDB, and it's not a news, kind of we already have it for more than a year. So kind of it's fine there. However, now is going from SQL to no reactive. At the moment, there are no reactive persistence for SQL. However, soon it could be brought by ADBA or R2DBC. So Pivotal said that if ADBA will have reactive API, they will drop off R2DBC and there would be only one standard. If it's not, probably there would be some competition between these two standards, kind of, and so far R2DBC a little bit ahead.
However, I would say that I haven't seen any activity in ADBA channel, mailing channel, for I guess for a half of the year, and R2DBC probably will be our future.
Most likely, yeah. So kind of, well, stay tuned. Kind of, there are a lot of interesting stuff that is going to happen in this area. So, and here are a couple of our takeaways. So, if you haven't read Web on Reactive Stack from Spring Framework, it's on the official site. It's very cool to understand why Reactive Web Stack is cool and why Reactive helps for efficiency. Also, there are a site, R2DBC.io, with a lot of information about R2DBC, kind of some code samples, tutorials, all that interesting stuff that you can read on your own.
Also, you can find there a few videos from Spring platform
this September, kind of. By the way, R2DBC was announced only 2 months ago. Kind of, so it's pretty new. It's kind of hot, really hot topic, and a lot of work is going in that direction now. And last but not least, we've talked today about a lot of how communicate with database in different ways, with asynchronous, batching, kind of, and even streaming. However, it was not the best solution. And today, a little bit later, we are going to talk about RSocket. It's a proposal how to do a reactive protocol over the network.
It's not a proposal, it's a reactive protocol.
Okay, it was already established protocol.
Right.
So
this is another story, another talk. So come to our talk, and we are going to explain why reactive is amazing again.
Yeah, there are some code samples behind these QR codes, and kind of we thank you for your attention and hope it was useful for you. And we have no time probably for a lot of questions. However, we still are here, so we kind of, do you have questions?
Yeah, we can have a question session on the backstage. So welcome, and thank you again, and have a great day and the rest of the conference. Thank you.
Thank you.